Good morning. Experiment meter bridge. Aim to find the unknown resistance using meter bridge and to also calculate its specific resistance.
Apparatus required. This is an instrument known as meter bridge. In this instrument, a scale is provided and the length of this scale is 100 centimeter or 1 meter. So it is known as meter bridge. A wire of manganese or constant ton, normally of manganese is used in this, which is of length 1 meter. So it is known as meter bridge. There are thick copper strips which are provided to flow the current in the circuit. They are thicker to minimize their resistance. The manganese wire is used because its resistance not varies with temperature. This is the device known as galvanometer. This galvanometer is used to detect the presence of the current, and galvanometer is used to note the balance point also. And this is the resistance box. Basically it contains several resistances, and the range of this resistance box is from 1 to 1000 ohm. This is the dry cell battery, which contain one cell, that is 1.5 volt is applied to the meter bridge. This is one-way key which is used to connect the proper circuit, in which when the key is closed then the circuit is working, and when the key is open then circuit is not working. This is the jockey which is connected to the negative terminal of galvanometer. It is used to calculate, it is used to find balance point on this wire by trial and error method. This the positive terminal of galvanometer, and this is the negative terminal of galvanometer. This is the wire of unknown resistance whose resistance is to be determined. This resistance is connected into the right gap of the meter bridge. This is the resistance box of range from 1 to 1000 ohm. In this resistance box, all the resistances are connected in series internally, as shown in this diagram. If two resistances are picked, then both are activated, and since they are connected in series, then the resultant resistance will be obtained by adding both. As when we pick 200 and 100, then the total resistance will be 300 ohm activated now.
Connections for meter bridge. The positive end of the battery is connected to other end of the meter bridge, and the negative end of the battery is connected to another end of the meter bridge. The resistance box, also the known resistance, is connected to the left gap, and the negative and the positive point of the galvanometer is connected to the middle point. The negative terminal of the galvanometer is connected to the jockey, which is set free to measure the balance point on the meter bridge. The wire whose resistance is to be calculated is connected on these ends of the meter bridge. Since the wire is being connected from one end to another end in between the copper strips, so there is some length of the wire which is beneath the copper strips. In order to correct these length, we use end correction method, and in order to take out this end correction, we shift the connection from this side to this side, and again from this side to that side, and we calculate the average of both the two readings.
First insert the key and then draw out the minimum resistance, because this method cannot be used for higher resistance. Then we can take the resistance up to 5 ohm only. This method is valid for lower resistance. Then take this jockey, and now we want to find out the balance point. The balance point can be measured from that end where the positive balance point can be noted from that end where positive terminal of battery is connected. As the jockey is moved on the wire, Then we obtain null deflection in galvanometer. Which gives the value of balancing length, and that length is 6.5 centimeter from the positive end of the battery. Then, using the formula of Wheatstone bridge, P upon Q is equals to R upon S, where P is the balancing length, Q is the remaining length, that is represented by 100 minus L. R is the non-resistance which is withdrawn out from the resistance box, which is equals to 1 ohm, and S is the unknown resistance. By using this formula, we can calculate the value of unknown resistance, which is in ohm. Because this wire is very small in length and having very small resistance, then the value is about 1 ohm. Now, by using the formula, resistivity is equals to unknown resistance, using the formula, resistivity is equals to unknown resistance. Meter bridge experiment can be written in manual under the following headings. This is the fundamental diagram of the meter bridge, in which known resistance is connected in the left gap, unknown resistance is connected in the right gap, and galvanometer and battery positions are indicated. Then objective, apparatus, theory, then table for length and unknown resistance, and the table for the diameter of the wire are taken in observation, calculation, then result, which gives the value of unknown resistance, specific resistance of the wire, then precautions, and finally sources of error. When we get the value of unknown resistance, then unknown resistance S, then we can calculate the resistivity of this wire also. The formula for resistivity is unknown resistance into area of this wire, area of cross section of this wire, upon the length of wire. The length of this wire is 50 centimeter. Area of cross section can be noted by the formula pi r square. R is the radius of this wire, which can be calculated by using a screw gauge, and then area of cross section can be determined. By putting this value in the formula, rho is equals to SA upon L, we will get the resistivity in ohm meter.